We shall align using the 4-step method and show how to calculate the amount of each move. Lifting the rear footings would tend to close the coupling at the top. The distance between the rear footing and the pivot, front footing, is a factor in how much the coupling faces will close at the top for any lift at the rear footing. Readings taken at the face of the coupling hub, which is 10 centimeters in diameter, and it is open at the top 0.127 millimeters more than at the bottom. With a 10 centimeter diameter coupling, if the distance between the pivot point and the rear footings was also 10 centimeters, then a 1-to-1 ratio is found, and lifting the rear footing 0.127 millimeters would close the coupling 0.127 millimeters at the top. If the distance was 20 centimeters between footings, the ratio would become 2-to-1, and the rear footings would have to be raised 0.254 millimeters to close the 10 centimeter diameter coupling 0.127 millimeters at the top. Realistically, we have assumed the coupling is 10 centimeters in diameter. The distance between front and rear footings is 50 centimeters, and the opening at the top of the coupling is 0.127 millimeters larger than at the bottom. We make a simple calculation. How many times will the coupling diameter go into the distance between the front and rear footings? The answer is 5 times. So, 5 times 0.127 millimeters tells us that a shim of 0.635 millimeters thick placed under each rear footing will bring the coupling into good angular alignment in elevation. The distance between footings is measured from center to center of the holding down bolts. Now, assume the shaft of the movable unit is 0.305 millimeters below the shaft of the stationary unit. Placing a 0.305 millimeter thick shim under each of its footings will bring the shafts into good parallel alignment in elevation. Steps 1 and 2 were obtained with shims, so they will not be lost while performing steps 3 and 4. Correcting angular misalignment in plan, the distance between coupling faces is 0.203 millimeters greater on one side than on the other side. Divide the coupling diameter into the distance between the front and rear bolts, and multiply by the gap. And so, the rear end of the movable unit will have to be moved exactly 1.016 millimeters. For alignment, place the dial indicator against the rear footing on the side of larger coupling opening. Set the indicator to 0 and place the screw jack in position at the opposite rear footing to move the equipment towards the indicator. Loosen both rear hold-down bolts and one front hold-down bolt. Turn the screw jack and move the rear end against the indicator until it registers 1.016 millimeters. Tighten all hold-down bolts and recheck the indicator. If it has changed because of tightening the bolts, then loosen the same bolts and readjust. Step 4 is to correct parallel misalignment in plan. With a dial indicator attached to one shaft or coupling, and the indicator button on the outside diameter of the other shaft coupling hub, let us assume it is 1.143 millimeters from one and the other. Now, the trick is to move the movable unit straight over 1.143 millimeters without disturbing the angular alignment made in step 3. Recheck to be sure parallel alignment is within 0.05 millimeters and that angular alignment has not been disturbed. Now you know the exact steps for aligning a motor and a pump or any other equipment combination.